January 17, 1945. The final brutal spasms of the Battle of the Bulge were grinding down into the snow-choked forests surrounding Houffalize. The air itself was a raw, white metal, scraped thin by sub-zero temperatures and the pervasive scent of spent gunpowder and burnt lubricant. In the narrow track leading toward the village, the crew of an M4A3 76W Sherman tank, callsign Kingfisher, huddled, their breath condensing instantly against the cold steel of the turret interior. The silence, deep and menacing, was broken only by the rhythmic, nervous clink of the driver's discarded K-ration can being kicked gently back and forth against the transmission housing. A tin of processed ham and egg, a square of dry biscuits, and a packet of soluble coffee, the American symbol of overwhelming industrial convenience, sitting like a mute, hollow god inside the war machine. The war had, by then, taught these men a brutal, reductive truth. The M4 Sherman, for all its virtues, speed, mechanical reliability, and sheer numbers, was a liability against the apex predators of the German armored formations. They had been baptized in fire that summer, facing the Panzerkampfwagen 5 Panther, a machine that redefined medium tank warfare and cast a psychological shadow across the Allied lines that no amount of industrial output could immediately dissipate. The Panther, born out of the shock of T-34 encounters on the Eastern Front, was not merely a tank. It was the physical manifestation of the German faith in qualitative superiority. Its great sloping glacis plate, 80 millimeters thick and angled sharply at 55 degrees, was a masterpiece of kinetic energy deflection. In the minds of German tankers, this armor created an impenetrable dome, a tactical sanctuary against the standard American M72 or M61 high-explosive and armor-piercing shot, fired by the standard 75mm M3 gun. For nearly a year, this expectation had held true. American rounds, even from the improved long-barreled 76mm M1A1 gun, a gun which itself was a belated response to the superiority of German armor, would often strike the Panther's front face with a sickening clang, ricocheting skyward. In a harmless fountain of sparks, a theatrical display of the Sherman's impotence, the German crew, insulated by steel and doctrine, would often not even feel the strike, merely registering a dull thud or a fleeting shudder, then resume the calculated hunt. This was the historical context, a technological imbalance that forced the Allies to fight an asymmetrical war of attrition. American crews entered combat burdened by the knowledge that they needed 3, 4, perhaps 5 Shermans to confidently destroy a single, well-positioned Panther. The very sight of the angular, low-profile silhouette emerging from the fog or tree line induced a chilling certainty. The first shot would be the Germans, and it would be fatal. The Kingfisher crew had accepted this calculus. They expected a terrifying, drawn-out duel, a statistical gamble against the formidable 75mm high-velocity KWK-42 L70 cannon of the Panther, capable of punching through the Sherman's frontal armor from distances that the Sherman couldn't even effectively engage from. The German expectation, forged in the doctrinal certainty of superior engineering, was of untouchability. They expected to dictate the terms of engagement, to shrug off incoming fire, and to destroy their enemy systematically. What they experienced in the late months of 1944 and the opening weeks of 1945 was a subtle, insidious erosion of this certainty, an experience born of tungsten, logistics, and desperation. The 76mm gun had been conceived long before D-Day, but its introduction had been a logistical and political struggle. General Patton, worried about the visual appearance of a larger muzzle brake and the perception of lower high explosive lethality, had famously resisted its widespread deployment, preferring the familiar effectiveness of the 75mm HE shell for supporting infantry. But the grim realities of the tank battles in Normandy, the unforgiving hedgerow country, the close-range ambushes, and the proliferation of Panthers made the up-gunning essential. The M1A1 and later M1A2 76mm guns gave the Sherman the necessary muzzle velocity to penetrate the thinner side armor of the Panther, or to chip away at its main armor at extremely close range. Yet the problem of the Panther's sloped 80mm glacis remained. Even with the new gun and standard armor-piercing capped ballistic capped APCBC rounds, the Sherman was still hopelessly outmatched frontally beyond 500 yards. This brings us to the true subject of the German psychological trauma, the high-velocity armor-piercing round, designated M93, or T4 in its developmental phase. This round was not mere steel, it was a dart of high density, impossibly hard metal, a tungsten carbide core sheathed in aluminum and mounted on a lightweight sabot. When fired from the 76mm gun, the sabot peeled away moments after, leaving the tungsten core, barely larger than a golf ball, to travel at a staggering 3,800 feet per second. It was a spear of concentrated kinetic energy, an arrow of pure physics designed not to defeat the armor through gradual pressure, but to overcome it through sheer, brutal velocity. The M93 was, by every measure, a secret weapon, not in its existence, which was known to Allied ordnance departments, but in its availability and supply. Tungsten was a rare strategic resource, its supply lines fraught with geopolitical challenges. The United States Ordnance Department was hesitant to distribute the round widely, rationing it out under strict control, often limiting its availability to only 1 or 2 shells per tank in a company, a tactical scarcity that turned the M93 into an ultimate last-ditch resort. German intelligence, therefore, never cataloged a consistent, measurable threat from this type of ammunition. They knew the M4 could carry a larger gun, but they believed they knew the terminal ballistic limits of standard American steel shot. They had meticulously calculated the expected defense of their armor against American and British rounds. The M93 was the variable they failed to compute. Back in the freezing Ardennes, the Kingfisher's commander, Lieutenant Dale Peterson, lowered his binoculars. A dark, skeletal shape was emerging from the shadows of the pine line, a Panther OSF. G. It was close, less than 300 yards. Too close for comfort, but perhaps close enough for a fighting chance. Peterson swallowed, the sudden dryness in his throat betraying the doctrine he had been forced to internalize. Engage, then move, then pray. In the gunner's seat, Sergeant Mitchum had already traversed the turret. The 76mm was pointed directly at the Panther's massive, intimidating front plate. Mitchum's initial rounds were the standard APCBC, a psychological habit, a necessity of conservation. Gunner, APCBC, glacis, fire. Peterson's voice was strained, high-pitched by the cold and the fear. The M1A2 spat fire and thunder. The round impacted the Panther. The familiar, sickeningly bright flash of a harmless ricochet erupted from the German tank's front, a small, arrogant firework against the gloom. The Panther's long gun immediately began to traverse, zeroing in. Time stretched. The crew inside the Sherman held their breath, expecting the blinding light and deafening whoomph of the German 75mm entering their fighting compartment. Gunner, AP. Fire! Peterson ordered, clinging to the slim chance of a lucky shot or a jamming gun. Another flash. Another spark. The German round did not come. The Panther's turret stopped traversing. Something was wrong on the German side. Perhaps a misfire. Perhaps the commander was still ranging the target. A lifeline. A fraction of a second of grace. Cease fire. Loader, damn it. Load the T4. Load the T4. Peterson barked, using the vernacular for the HVAP shot. The loader, Specialist Ramos, fumbled through the sparse rack. The M93 round felt different. Lighter than the conventional shot. Its tungsten core housed in a delicate, almost fragile-looking aluminum sheath. Ramos slammed the round into the breech. T4, loaded. Peterson didn't wait for the gunner to correct his aim. The Panther was too close. The moment of its hesitation was a gift that would not be repeated. Glacis. Fire, now. The 76mm fired a third time. This was not the deafening boom of the steel shot, but a sharper, higher-pitched crack, the sound of extreme velocity. The projectile, shed of its sabot, impacted the Panther's glacis. There was no flash. There was no bright ricochet. Instead, there was a sound that German tankers had never heard before from a Sherman at this range. A horrific, metal-tearing rip, like a sheet of industrial-strength paper being torn, followed instantly by the hollow, wet thump of the core ripping through, the 80mm plate. The tungsten slug, only 23mm in diameter, drilled a precise, clean hole through the Panther's main armor, carrying with it a molten cone of steel and creating a devastating cascade of high-velocity spall that vaporized the gunner and instantly ignited the stored ammunition in the hull. The Panther did not immediately explode. It began to burn, a slow, sickly fire that grew rapidly into a roaring inferno from the inside out, the turret jamming mid-traverse. The hatches blew open, and two terrified, burning men spilled out into the snow before collapsing. The Kingfisher crew sat in stunned silence. The K-ration can at the driver's feet clinked once more, softly. This was the historical evidence in action. This single, devastating penetration, repeated across the battlefields of the Ardennes, the Saar, and the Rhine, began the slow, torturous death of the German armored superiority complex. The German war effort, already strained by material shortages, had placed a philosophical emphasis on armor quality, on the idea that superior engineering could perpetually defeat superior production numbers. The Panther was the embodiment of this philosophy. Its sloped armor was designed to multiply its effective thickness against conventional kinetic energy rounds, giving it the necessary edge to survive long enough to exploit its own powerful gun. But the M93 HVAP round, utilizing the principle of momentum over mass, circumvented this defense. The formula for kinetic energy, E mever K inordadider and frac 2 bar m $2, dictates that velocity, V dollars, is exponentially more important than mass, P. The tungsten core was lighter but faster, substituting mass for speed and delivering an equivalent or superior punch compared to a much heavier, slower standard round. The high velocity and density of the M93 core, coupled with its small diameter, concentrated the force onto a small area, allowing it to punch through the 80mm steel with little regard for the slope that had defeated countless other shells. We must understand the sheer audacity of this engineering. The Panther's 80mm glacis was effective against the 76mm APCBC, only up to around 100 yards. At 500 yards, the standard round might penetrate 70mm of flat vertical armor. But the HVAP, due to its velocity, dramatically altered the penetration curve. At 1,000 yards, the M93 round could reliably pierce 100mm of vertical armor, translating to a viable penetration chance against the Panther's front face at distances where the Sherman was previously considered defenseless. The German armored doctrine and industrial focus had never seriously considered that the Americans, masters of mass production, would deploy such a technically demanding, rare earth metal-dependent weapon in significant numbers. They expected a slugfest of steel, not a lightning bolt of tungsten. The transformation was immediate and profound, affecting both sides of the conflict. For the American tanker, the ability to load the M93, the secret weapon, created a reservoir of psychological confidence. No longer was the engagement a predetermined loss, a sacrificial duty. It became a tactical choice. The sight of a Panther, once a source of paralyzing fear, became a test of nerve, a moment to reach for the precious, reserved round. This confidence, born from the simple fact that they could penetrate the enemy, was more valuable than 1,000 extra Shermans. It fundamentally changed the American soldier's perception of his own equipment, restoring a lost sense of parity and capability. The crews operating out of the abundance of the American supply line, an abundance symbolized by the endless supply of those dry, functional and identical K-rations, had finally been given a tool to match that abundance with quality. The K-ration, always in supply, bland but sustaining, represented the sheer weight of a fully mobilized nation. For the German crew, the transformation was one of sudden, crippling vulnerability. After-action reports from captured German tankers and maintenance crews speak not just of penetration, but of bewilderment. They would discover a small, almost surgical hole in the thickest part of their tank's armor, a hole too small for the damage it caused, a signature unlike anything they had encountered before. This was not the explosive impact of a high-explosive anti-tank round, nor the messy, spalling damage of standard steel shot. It was a precise, catastrophic wound. The psychological impact was amplified by the rarity of the round. Because the M93 was sparingly used, its penetration seemed arbitrary, random, and terrifyingly unpredictable. A German crew might survive 4 or 5 Sherman engagements with their armor proudly shrugging off hits, only to be instantly, violently destroyed in the 6th engagement by a round they did not know existed. This created pervasive paranoia. The myth of the Panthers' invincibility, which was as crucial to German morale as its steel, was suddenly broken. If the Sherman, the Ronson Lighter, the Tommy Cooker, could penetrate the glacis, then their only real protection was speed and camouflage, not the physical armor they had placed their faith in. Historical evidence from late 1944 shows an increase in tank abandonment by German crews who reported non-specified armor-piercing damage or simply inadequate protection. The high casualty rates among Panther crews, many killed by the massive internal spall from these HVAP hits, led to increased hesitation. Commanders became reluctant to commit their Panthers to frontal assaults, preferring to use them in concealed, long-range defense, ceding the tactical initiative to the Allies. The German ideology, that genius engineering would always trump democratic mass production, was being proven false by a single, specialized, mass-produced projectile made possible by an industrial base capable of sourcing, refining, and manufacturing thousands of precise tungsten cores. The American soldier, munching on the dry crackers and processed cheese from his K-ration, a meal that cost pennies and was churned out by factories thousands of miles away, was fighting a war supported by a virtually infinite, elastic supply chain. The German tanker, whose Panther cost thousands of man-hours and barrels of precious fuel, was fueled by increasingly scarce, often ersatz rations, and was reliant on an industrial base crippled by Allied bombing. The K-ration, with its simplicity and ubiquity, became an accidental symbol of the American system. Functional, unglamorous, but crushingly available. Its presence, always dependable, contrasted sharply with the bespoke, complex, and ultimately brittle German logistical structure. The effect of the HVAP was amplified by the cumulative nature of American firepower. While the individual 76mm HVAP round was decisive, it was always delivered within a wider context of overwhelming superiority. The Germans were fighting a qualitative battle, the Americans a quantitative one. The HVAP simply raised the quality of the quantitative machine just enough to achieve parity. And in that parity, numbers always win. Let us return to the aftermath of the Kingfisher's single shot. Peterson ordered his driver forward, cautiously toward the still-smoking hulk of the Panther. The scene was one of finality, not of a hard-fought duel, but of abrupt, definitive termination. The small hole on the glacis was almost insignificant, yet it represented a breach in the psychological wall of German defense. The smell of burning rubber, fuel, and metal hung heavy, a toxic incense over the battlefield. The American crew collected themselves, the adrenaline receding, leaving behind a cold, shaky exhaustion. They had done what was considered impossible just 6 months prior. They had killed a Panther, frontally and with a Sherman. The war's last months, the push across the Rhine, the final disintegration of the Wehrmacht, were colored by this technological catch-up. The Germans, belatedly recognizing the need for better anti-tank weaponry, desperately tried to develop countermeasures and new, even thicker armor schemes. But it was too late. The tide of American manufacturing, personified by the steady, unceasing flow of M4 tanks and the sporadic, terrifying appearance of the HVAP round, had turned the war of material. The HVAP round was a small footnote in the grand scale of the war's logistics, a specialized, rationed piece of ordnance. But its impact was seismic. It proved that engineering excellence, when starved of resources and deployed in finite numbers, could not withstand the relentless, adaptable, and massively funded industrial engine of a unified democracy. The tungsten core, born of sophisticated metallurgical science, was ultimately a product of simple, boundless capacity. It was the same industrial capacity that churned out millions upon millions of K-rations, ensuring that every soldier, from the frontline infantryman to the tank commander, had a minimal necessary level of sustenance, day in and day out, regardless of the tactical situation. In the end, the war was not decided by a single piece of flawless German steel, but by the American ability to adapt, produce, and ultimately to choose when to deploy a small, decisive counterpunch. A tungsten fist in a velvet glove of mass production. The German tanker fought a war of exceptions: the exceptional tank, the exceptional crew, the exceptional defense. The American tanker fought a war of overwhelming standards, and the HVAP transformed that standard just enough to break the exceptional. The memory of the Panther, burning silently in the snow, the small, clean hole, a silent indictment of a failed ideology, remained with the crew of the Kingfisher. They survived the war, but they never forgot the sound of that third shot, the high-pitched crack that heralded the death of the invincible German tank myth. The Sherman, often derided, was the vehicle of a democratic, pragmatic army. It was not perfect, but it was capable of carrying the answer to its own problems within its hull. The K ration, always there, symbolized the industrial democracy that provided it. That same vast, unstoppable engine that produced processed meat, coffee powder, and biscuits in incomprehensible volumes also produced the rare, precise, and deadly tungsten necessary to defeat the enemy's best armor. The great truth of that conflict, borne out in the Ardennes snow, is this: freedom, expressed through the unstoppable output of a fully mobilized society, is not merely about having better ideas. It is about having the capacity to realize those ideas, to correct failures with speed, and to deliver specialized, decisive tools to the men on the ground, supported by a logistical avalanche. The German tanker, whose faith was placed in the inviolable sanctity of Krupp steel, learned the hard way that when the industrial might of a democracy is fully roused, even the most perfect piece of totalitarian engineering can be shredded by a piece of tungsten, no bigger than a finger, fired from a gun that was never supposed to be a threat. The secret of the HVAP was not the material. It was the entire system of democratic production that allowed it to exist at all, transforming a war of quality into an overwhelming, irreversible war of kinetic energy and consumption, a reality as brutal and constant as the cold steel of the K ration can.